Hello, we are in Chapter 5, Section 5.6, Rationalizing Denominators. In this video, we are going to go over problem number 5, in which in addition to rationalizing denominators, we will review how to simplify radical expressions. Starting in part A, I'm going to simplify each of those radicals first before performing the division. Starting with the denominator to acknowledge what irrationalities I still have to get rid of, I split that into the square root of 11, and in the remaining factor I want to see all the perfect squares. Now c to the power of 10 can be presented as the square of c to the power of 5, since 5 times 2 is 10, and then y to the power of 6 can be presented as the square of y cubed. Again, since 3 times 2 is 6. Now those radicals will be easy to simplify except for the square root of 11. And so far I will rewrite the numerator as is, so I know what I'm dealing with in the denominator first. As I said, the square root of 11 stays as the square root of 11, but then the square root of the square is just what we have as the base, which is c to the power of 5, and similarly y cubed from the other one. Now I know what I'm dealing with, and I know that I will have to multiply by that square root of 11 in the denominator to rationalize it. So I want to keep the square root of 15 separate in the numerator, and then simplify everything in the remaining factors. So since, again, we have square roots, we are looking for perfect square powers, and c to the power of 15 is c to the power of 14 plus 1, and 14 is 7 times 2. So c to the power of 14 can be presented as the square of c to the power of 7, and then the plus 1 is another factor of c. Now with y squared, it's already a perfect square, so we just leave it as is. Now to rationalize that denominator, I need to multiply by the square root of 11 because that's the only irrationality in there. So I multiply that square root of 11 into both the denominator and the numerator. And then starting with the denominator, the square root of 11 squared is 11. And I leave all the other factors as they are. In the numerator, the square root of 15 multiplied by the square root of 11 will give me the square root of 165. And I will simplify the remaining factors. I have the square root of the square of c to the power of 7, leaving me with that c to the power of 7, and then another square root of c, of course. And then the square root of y squared is just y, since we assume that all variables represent positive numbers in here. The denominator is already rationalized, so it's just a matter of simplifying our answer. On top, we can see we have two square roots that we can put as a single square root of the product of the radicands, 165 times c. And then we acknowledge we have common factors of c between the numerator and denominator with smaller number of those c's in the denominator, so we present c to the power of 7 as c to the power of 5 times c squared. And then also in terms of y, we have 1y on top and 3 on the bottom, so we will present y to the third in the denominator as y to the power of 1 multiplied by y squared for easiness of dividing out common factors between the numerator and denominator. So the factors of c to the power of 5 can be divided out, the factors of y can be divided out, and that leaves us all together with that square root of 165c multiplied by c squared on top, and 11 multiplied by y squared on the bottom. And that's it in part A, since 165 doesn't have any perfect square factors. Now moving on to part B, I acknowledge that there are lots of simplifications possible between the radicands of the numerator and denominator. So instead of first dealing with each of them separately, I'm gonna rewrite that as a single cube root of the radicand of the numerator over the radicand of the denominator and perform the simplifications there. And so I have a single cube root of the radicand of the numerator, 80x to the 4th y squared, over the radicand of the denominator, 10x squared y, or y to the 1st, in other words. So 80 and 10 have common factor of 10 that can be divided out. X to the 4th and x squared have a common factor of x squared, so I divide this out, leaving me with x squared on top, and one of the y's also simplifies. So that gives me the cube root of 8x squared y, and the only perfect cubic factor is 8, and I will keep the rest under the other cube root factor. Cube root of 8 is 2, and that leaves me with the cube root of x squared y, and no further simplifications are possible, and we're done.